Displacement in a simple pendulum and its effects on oscillation. How much faster or slower does a pendulum oscillate when the displacement changes? Our observations are that displacing a pendulum causes it to move faster and farther, which inspired us to test what the effect displacement has on oscillation. Question: how does displacement of a weight on a pendulum affect the oscillation? Our hypothesis is if the weight is raised higher, then the oscillation will be slower because the weight's inertia causes it to move farther when it's moving faster, which is a result of being dropped higher. The variables are: the independent variable is the height at which the pendulum was dropped. The pendulum weight was dropped. The dependent variable is the amount of oscillations per second. The constants are planet we are on, which is gravity, and height of string, and and temperature and weight, etc. The constants are, that was the constant, and then the materials are weight, string, and the weight string 40 centimeters long, not counting knots and tied-off parts, C-clamp, meter stick, Microsoft Excel and PowerPoint for graphing and calculating data, software clock with seconds, a Lenovo X201 tablet, model number 93098X and AP5. I know. Procedure. First, you have to measure the height that the weight will be let go at and record it. Next, start the stopwatch while at the same time letting go of the ball. Count full oscillations, number of times the weight goes back and forth. After 10 seconds, record the number of times the weight oscillated. Repeat for at least 5 different levels. Here's a sample from one of our trials. Then, of course, this trial was excluded because the pendulum hit the table. The trials taken off the camera did not fail. Here's our data table. As you can see, it looks you can kind of see a pattern from it. Here's our graph. So on the y-axis, it's the oscillations per second. On the x-axis, it's the height. Here's so the number of times the weight oscillates per 10 seconds at the predetermined heights was recorded. This was divided by 10, which gives the number of oscillations per second. Conclusion. Our hypothesis was if the weight was raised higher, then the oscillation will be slower because the weight's inertia causes it to move farther when it is moving faster, which is a result of being dropped higher. This hypothesis was correct because the number of oscillations per second decreased exponentially. When the pendulum was raised only 2 centimeters, it oscillated 1.2 times per second. At 5 centimeters, the pendulum oscillated 0.9 times per second. However, at 20 centimeters, the weight oscillated 0.7 times per second. Error analysis. This hypothesis did not specify data trends. The C-clamp we used interfered with the pendulum if it was dropped from too high. Extensions. Objects that rely on the pendulums will be affected by the amount of displacement. How long does the length of the pendulum affect oscillation? How fast would the weight need to be to move at a full 360-degree revolution? Group members. Are me. I did the experiments and made the graphs. My lab partner recorded the trials and prepared the experiment. We both created video and PowerPoint presentation. Anyway, that's it. Thanks for watching.